Started. At the top it should say, was it negative exponents? All right, and this is just a real world type problem involving negative exponents. Okay, so it says the table shows the approximate wing beats per minute for certain insects. The ratio in simplest form that compares the number of wing beats for a butterfly to a housefly is 1 over 100 or 1 over 100 or 1 over 10 squared. What is the relationship between exponential form and standard decimal notation? Okay, so basically all it's saying is, how would we express this as a decimal? What's that relationship? They're the same, right? So how would we write it as a decimal? Anyone?
0.01.
0.01. Good job. So 0.01. That's a dot. There we go. Okay? Does that make sense? 1 over 100 equals 0.01, right? Everybody agree?
Okay.
All right. So it says complete the first 4 rows of the table showing the exponential and standard decimal notation forms of powers of 10. Okay, so it's basically just saying complete these first 4 rows right here. So 10 to the third power, what does that give us?
10 times 10 times 10. 300.
300?
Oh, 1,000.
Y'all are doing exactly what I said is going to happen. You're not multiplying that exponent by that number. The base, you're not multiplying it. That exponent tells you how many times you're going to multiply 10 by itself. Okay, that 3 tells you I'm going to multiply 10 3 times. 10 times 10 times 10. Not 10 times 3. And get, that's wrong. Don't do that.
1,000.
Common mistake. Not 900. Where did you
We're
get
supposed to
900?
10 times 10 times 10. We're supposed to multiply 10 times 10 and say like if you get 100 and then 100 times 10, and that's what gives you 1,000.
Yeah. Or you can just put it in your calculator. 10 times 10 times 10, like you could just type it like that. It'll still give you 1,000. Or you can put 10 to the third power. It'll give you 1,000. Okay, so the next one says 10 to the blank power equals 100. Gavin.
2.
Gavin? Not 1.
2.
2. 10 to the second power. So 10 times 10, right? 10 times 10 equals 100. Okay. What's up, Matthias? Yeah.
It's 10.
10. Good job, Matthias. 10.
Sometimes in some cases, an exponent will tell you how to.
The fourth one is what? It's 1, right?
What's that 1?
I thought it was 0.
Anything to 0 power is 1. Always.
Always, 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 always.
No matter what number.
Any number.
Always 1.
Okay? Any number to the 0 power is going to equal 1. Any questions about how we got those numbers? Everybody understand that? Okay. So number 3 says, what operation is performed when you move down the table? So from here to here or here to here, what's happening?
It's decreasing.
It's decreasing, right? It's decreasing. How is it decreasing?
It takes away zeros.
Takes away zeros, or it's decreasing by 10, right? So if it's decreasing by 10 every time, what's another, what operation is that? Huh? Division, right? We're dividing by 10 every time? Division. Whoops. So division. So what, number 4, what happens to the exponents? Goes down by 1, right? So goes down, oops, by 1. Wait until I get that stylus and we're gonna be in there. So number 5, extend the table to include the next 3 entries. So it's going down by 1 every time, right? So what? So 10 to the negative 1, right? And how would that look over here on the other side?
1/10.
Say that out again.
1/10.
1/10. Or, how's that as a decimal?
0.110. 0.1. Sorry. I said it.
So, the next one? Ten to the negative. Whoops, that's a big negative. -2. 1/100 or
0.01. Let's go. 1/0.
and then the last one? 1/1000.
0.00.
And what is it over here? 10 to the -3.
Let's go.
Pretty simple, right? Good job, good job. Number 6, use the relationship shown in the table to predict the standard decimal notation for 10 to the -7.
Oh.
So how would 10 to the -7 look? Gavin? What number is that?
1,000,000.
Neither do I.
Million.
Is it 1 million?
10 million.
10 million.
Bro.
1/10 million. Or, if we notice, it was 10 to the -7, right? Right? How many zeros do we have?
4.
That's 4 zeros.
7.
Didn't she say he had some more?
Yeah, then we just have to go down and. Okay. So, there's 7 zeros. Pretty easy, right? Notice how over here, it was 10 to the -3, there was 3 zeros. 10 to the -2, 2 zeros, -1, 1 0. Make sense?
Oh, I get it. Could have told us this before.
Yeah, I think it only works out with 10s though. Like that, anyways. Shouldn't have it out in the first place. Any questions on page 42? Or what is this? 41, I'm sorry. Nope. Everybody good?
What did you say?
Any questions?
No, sir.
All right, good job. So go ahead, we're going to go to page 42.
Oh, yeah.
And we're going to talk about zero and negative exponents, okay? So if you read at the top, it says any non-zero number to the 0 power is 1. So that's what we just did when we had 10 to the 0 power, it equaled 1. Any number to the 0 power is going to be 1. Any non-zero number to the negative n power is a multiplicative inverse of its nth power. So basically, all that's saying is any number to the negative power is its reciprocal of that power. Okay?
Also like 30. So like since it's negative 3.
If it was so look right here, we got an example for us. So 5 to the 0 power, any number to the 0 power is going to equal 1, right? And then here's the example of the negative power. So 7 to the negative power is just the reciprocal, so we're flipping it, and now the power is positive. Okay? So in order to flip it, we just put it under a 1, and now the number's positive. Make sense?
Yes, sir.
We just flipped it and switched the sign. Flip and switch. Got it?
Sure.
Any questions about that?
I got the first.
Flip and switch, flip and switch.
Yeah. Yeah, freshman. Sir, can
Oh,
I
so
do
you're talking about A?
Yeah.
Yeah.
No, well, number 1.
Number one.
Well,
Examples.
Number 1, it tells you what it is. What do you mean, you weirdo? Look, number 1 says 6 to the negative 3
I'm talking about A. I'm talking about
Yeah.
equals 1
I
over
know
6.
it is. I know
I'm
it
talking
is.
about A, sir.
I know it
Oh, you're
is.
talking about A?
Yeah.
I know it is. It's 1 to the 1 over 7 to the second power.
1 over 7 to the second power.
Or it
Perfect. Or what?
can be like 1 over 7 times 1 over 7.
Oh,
Correct.
which is 107.
What about B? Matthias?
1 over B, 4.
1 over B to the 4th power, right?
Fourth power.
There we go.
Sorry.
1 over B
To the 4th power.
to the 4th power. Number 5, or letter C, that should be an easy one. 1, right?
Number
E
C.
was number 1.
We just went over that. Any number to the 0 power is 1.
No matter what.
No matter what.
Can I do D?
Yeah, go for it.
1 over M to the 3rd power.
Perfect.
We're on like on roll.
On a roll. We're killing it. Everybody understand that?
Sir.
Pretty simple stuff? Anybody not understand that? It's okay if you don't. I just need to know. Everybody's good?
Yeah.
Okay. So we're going to go ahead and keep on moving on.
Are we gonna do like got it ones?
Well, let's talk about what E through H are going to be about first. So if we look at the examples now, we're switching from the positive and we want to switch it back to the negative exponent, okay? So we're still doing the same thing but in reverse. So now it's a fraction, we're putting it back onto the top and it's negative again. Okay? So if we look at the example right here, we have 1 over 5 to the 2nd power, right?
That's one.
So we put it to the top.
I know. I called it first.
Hold on. We put it to the top, and now it's negative, right? Alright, since y'all are so ready, we'll see. I won't even talk about number 4.
8 to the negative 3rd power.
I know G.
Ooh, terrible
I
3.
know G, sir. I know F.
Terrible 3. Huh, that's gonna have to do. You know G?
Yes.
What about F?
F is
Be careful with that.
Oh, I know. Wait, I know.
What's up, Mauricio?
2 to the negative. Wait.
2 to the
Yeah,
negative
2
2.
to the negative 2.
Good job. There you go. Good job. So why is it 2 to the negative 2 and not 4?
Oh, I know why. Because you have to.
Somebody else.
Oh, because you said the reciprocal.
All you gotta do is look at these.
No, you simplify.
You simplify.
You simplify it. So 2 squared equals 4, right? But it has to be negative because it's on the top now. Good job. What about G?
Oh, I got that one. I know that one.
Sir.
And somebody else. Yes, ma'am. Perfect. Good job. Now H, this one might be a little tricky. Who knows H?
Look at the number, look at that number 27.
You know it, Matthias?
Look at the number 27, what is it?
Wait, I know it.
You go.
It's 3 negative 3 negative 2. I mean 3 over 2. Over 2.
You're so close.
You're close.
It's 3.
Anybody else wanna give it a shot? You're
Very, very close.
How many times you gonna multiply that 3 to get to 27?
9.
So it's 9 times?
9 times
No.
3.
How many times?
9
you multiply
times 3. I know what
They
number.
said the negative
3
nine.
to the negative power. Yeah.
How many times,
Oh my
Mauricio?
gosh, I
How
can't
many
say
times
that
you
part.
multiplying 3 by itself to get to 27?
3.
3, right?
3.
I said 3.
That's why I asked you how many times. So what is it? What is it? It's 3 to the
Negative power. To the third power.
to the negative
Negative
third power.
I can't say that.
Alright, so you simplify, you have to work, sometimes you gotta work backwards. Okay?
You should have said the instructions.
They wanted to jump ahead.
I
Yeah.
looked at the instructions, that's how I really did
And that's good. Some people don't read the instructions, they just jump right into it.
So any questions about these?
No, sir.
That was pretty good. That was pretty good. Y'all did really good.
Why is it so simple now?
Cause this is how we do it. It's how we do it over here in these streets. I know that's right.
That's how we do it on Silent Sunrise.
Yep. Uh-huh. All right, guys. So we'll go ahead and we're gonna go to page 43. Okay, 43. And this problem right here is gonna help what I said from page 1, if you remember, or page 41. So let's look at the example real quick. Example number 5. 1 human hair is about 0.001 inch in diameter. Express the decimal as a power of 10. So if we look at this example, 0.001 is the same thing as 1 over 1,000, correct? And then they simplify 1,000 to 10 to the third power, okay? And then they convert it to a negative exponent. So they flip it and switch it. So 10 to the negative third power, and that's what 0.001 means. Got it? Make sense? That being said, let's look at letter I. Letter I. A water molecule is about 0.000000001 meter long. Express the decimal as a power of 10. So how do we do that? Express this decimal as a power of 10. So we want to write it like this. You know it straight up? Let's see. What's your name, bud? Zachary. What do we got? 10 to the negative what? To the negative 9. So how many zeros do we have?
Yeah, it is 9. It is 9.
Sir, but if you did it as a fraction, it would be
1,
1
2,
billion.
3, 4,
1 over
5.
billion.
Yeah, it would be 1
1,
billion.
2, 3, 4, 5, 6.
So let's see.
1, 2, 3, 4, 5, 6.
We're right here, right?
Yes, negative.
1 billion.
We go 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, we gotta get on the other side of the 1, 2.
10.
10 spots, right?
So you're not counting the
That's 100
zeros,
million.
you're counting the spaces.
The spaces. 10 spots, right?
So it's
So as a fraction, that'll be what? 1 over
10 million.
10 billion.
100 million.
1, 2, 3, 4,
4,
5, 6, 7,
8.
8, 9, 10.
10.
That's
100
that's
million.
So 10 billion.
That's what I got on my paper.
That's too much.
I want that much money.
I do too.
You want that much money? 1 over 10 billion?
Wait,
No, I want 10 billion.
No, the 10 billion.
Yeah, she
There's
wants
a
1 over 10
difference.
billion.
So how would we write that over here as our exponent?
10 to the third.
10 to the negative.
10 to the negative
9, 10
Nine.
power.
negative 10.
10. Oh yeah, 10.
Negative 10.
I got it.
There's 10 zeros, right?
Yes.
10 to the negative 10.
I'm so proud of myself.
Good job, Mauricio.
Oh, it's 1 0. It's 1 0.
Oh man, let's move that there.
Doing good.
Broke it.
Wait, I think I know.
I know number
No,
J.
he doesn't.
think I know
Don't
J.
answer.
I know
I know
letter J.
L. I know L. I raise my hand
He
first.
doesn't know.
Alright, Matthias, what's a J?
1 over X, power, over to the 4th power 2.
There you go.
There we go. Yeah, it's so simple now.
1 over x to the 4th power, right?
4th power.
To the
K-
4th power.
K's, can I do K's?
Yep.
Okay.
Oh no, cause I'm gonna do the N.
Here, I'll do K then.
I'll do K.
I'll do K. Whoever dare do K.
You can do K.
That's a lot of K's.
Our bet.
K, K, K.
Whoa!
It's 1 over, wait, yeah. 1 over Y to the 3rd power, right?
To the 3rd power. Good job. I'm gonna zoom in here so I can write better.
Alright, what about L?
What about L?
2 over T to the 7th power.
2 over t
2T.
to the 7th power.
Look at that one.
Perfect. Right? So if we looked at our, you were able to look at our example, right?
Look at this.
Isn't it 1 over
Power
2T?
to the 7th power.
Wait,
So
at
look,
it.
he said 2,
Example.
he said 2 over t to the 7th power.
Oh.
So if we look at our example, on the example we have 3r to the negative 10th, right? So they factor the 3 out, the 3 went on the top, then we had r to the 10th power, right? So that's exactly what he did. He factored the 2 out,
Nice.
the 2's on the top, so 2, whoops. 2 over t to the 7th power.
I know M.
I'm doing it.
What's m?
It's 9 over B. Oh wait, no, it's 1 over B, right?
No.
Cause it's a 0.
I know it's third. I know it's third. I know it's third.
It's
2.1.
No.
Wait, hold on.
Can I write this stuff down?
which one?
That's in there.
Letter M?
Oh,
Yes, ma'am.
it's
9 over 1? Or just 9?
9.1. Oh, 9 times 1. Oh my.
9,
What
what?
did you say about the exponent of 0?
9 times 1.
It makes
It says
It
right
makes
there.
1, right?
9 times 1.
So 9 times 1, what is 9 times 1?
9. Here we go.
9.
9. Let's go. Come on, go roll now.
Good job.
The exponent is,
Come on, Chico.
is
What?
that variable.
Come on, man.
Alright, how much time we have left?
Yep, like 8
Like
minutes.
4 minutes, 5 minutes.
So what we're gonna do is on page, we're gonna go to page 44.
Let's go.
44. We haven't gotten this far. And we're gonna have volunteers go up on the board and work them out.
I'm gonna do the first one.
Hold
I wanna
on,
do the first one.
Hold on, Matthias.
Oh. He said, I'm about to blow your mind.
You can see I switched to the elbow for this.
I'm gonna do the first one. Try not to jump over. This is the first one. You did great.
Alright, we're gonna do number 2.
I'll do number 2.
Number 3. No, you're doing 1. We're gonna do number 3. Don't make us call on them, 'cause if you hadn't answered, then, and you hadn't asked questions, then that means you already understand what we're doing, so we call on you to work the problem out, then there shouldn't be an issue. Abby is gonna do number 3.
Yep.
Abby is gonna do number 3. If you don't mind
Didn't I
asking.
just blow your mind?
Alright, do we agree with number 1 and number 2?
Yeah.
1 over 2 to the 4th power for number 1. Does everybody agree with that?
Yeah.
Alright, good job, Matthias. Good job.
Ow.
And number 2,
That's number 4.
It's 1 over 4 to the 3rd power.
1 over 4 to the 3rd power. Everybody agree?
Yes, sir.
Good job. Good
Can I do
job.
3?
Abby's doing 3.
Can I do
Jacob,
5?
you can do 4.
Can I do 64? It's the tiniest writing ever. But good job. 1 over a to the 4th power. Everybody agree with that one?
Yeah.
Really good job. Really good job.
No, we can talk about it.
No, I read that whole 36.
Okay, so we got 2 minutes.
Yeah. Can I do number 4?
Let's finish up number
Can
4
I do
real
number
quick.
5?
Oh my gosh.
Alright, any questions on what we just did?
Good job.
Alright, so. Books need to be put up, calculators, this side of the room.
Listen to Coach Davis. Listen up.
This side of the room, go ahead and put your books up and the calculators quickly. This side, put up your books.
You saw put your books up while they're putting up the calculators. Then when they're done, you put your calculators up.
Okay, this is tomorrow.
Pretty good job today. Best class so far.
That was light work.
Light work.
Oh, man, my arms are sore on my shoulder. Hooping yesterday. My brain hurt my back.
Your backpack.
No, it's on my back.
Come on now.
Oh, is it running?
I wasn't running.
Oh, yeah.
Yeah, when you did that. Yeah, I took that.
What do you think that was? The double degree box. That one's kind of like I get you now. Yeah, I think
Are you serious?
Good job, Davis, guys.
And we have to show you how to access. Hey, you gotta be in a seat to be dismissed, not standing at the door, that's not how we roll.
in a seat.
In your seat. In your seat.